Assalamualaikum everyone and greetings. Today me and my team are going to present about our continuous assessment which is techniques of differentiations from Code Math 1A3. So the first question is explain the meaning of differentiations and what are the techniques of differentiations. Differentiation is a concept in mathematics where we try to find the derivative of a function. The derivative of fx with respect to s is the function of f prime x and is defined as f prime x equals to limit h approaches to 0 fx plus h minus fx over h. Where do we use differentiation? For example, in physics where we try to find the rate of change of velocity. So the first technique is chain rule, where we use the basic derivative of functions to find the answer. Secondly, we use product rule, where we use the formula f prime x equals to u v prime plus vu prime. We take the u and the v from a given equation and we differentiate the u and v from the equations. Lastly is quotient rule, where we use the formula dy over dx equals to vu prime minus uv prime over v square, which is the same case as product rule, where we are given an equation and we take the u and the v from the equation and we differentiate from the u and v given.
Okay, now let's move on to the question number 2. So find dy over dx for the following function. So the question A is 3x squared second x plus 2. So when we see this question, we know that actually it has two parts. The part number 1 is 3x squared and the part number 2 is the second x plus 2. So when we have a two part, actually we can use the product rule theory. So this is the formula for the formula for product rule is dy over dx equal to uv prime plus vu prime. So you need to know that this is u and this is v. So we need to find the u, v, u prime and v prime. So u, just copy from the question. So u, we have the 3x2 and u prime we need to differentiate the u. So same with this situation. So we have 2x the power, you bring in front and you meet the 3. So multiply with 3, you get 6 and x, we have a power of 2, so minus with 1, you get x. So settle for u and u prime. So for the v, also you also copy from the question. So second x plus 2. And then so for v prime, you need to differentiate the v. So second something which is x plus 2 is equal to the second x plus 2 times x plus 2. So I settle differentiate the second. Inside the bracket, I also need to differentiate. So the x is the 1. So the 2 is the constant. So the value is 0. So you don't need to write. So it's equal to 1. And then when we have the value of u prime, v and v prime, we need to substitute with at the formula. So dy over dx is 3x2. So 3x2 is the u. Second x plus 2 times x plus 2, 1 is the v prime plus second x plus 2 is the v and 6x is the is the u prime. And then just settle the equation. So we get 3x squared second x plus 2 times x plus 2 and then plus with 6x second x plus 2. So actually this 6x we bring in front. So this is the answer for the question 2a. Okay, now let's move on to the question 2b. So the question is find dy over dx for the following function y equal to 4x plus 2 over cos x. Okay, so actually this is different from a. We also have a two part, but the part number 1 is this and the part number 2 is this. So with this situation, we can use the quotient rule theory. So for the quotient rule theory, the formula is dy over dx equal to vu prime minus uv prime over v squared. So this is the formula for question. Okay, so you also need to know that this is u and this is v. So after we have the question, we also have the formula that we need to solve this problem. We need to find the value of u prime and also v prime. So for u, like I said before, just copy from the question. So u we get 4x plus 2 and u prime. So for u prime, you need to differentiate the u. So the u prime is 4 and for v, same, you need to copy from the question. So cos x and v prime, you need to differentiate the v. So cos something which is cos x is the negative sine x. Okay, so we have the value. So we need to substitute the value to the formula. So dy over dx, we get cos x. So cos x is the v. 4 is the u prime minus 4x plus 2 is the u, negative sine x is the v prime, and divided by cos x squared is the v. Okay, so just a little reminder, just don't forget about the square, which is the power of 2. And then just solve the equation. So you get 4 cos x plus 4x plus 2 sine x over cos 2x. Okay, the answer for the question 2b is this. For question 3, given y equal to 3x minus with e power of 2x plus y minus tan 4y equal to 0, find dy by dx using implicit function. So y log 3x, we use product rule. The formula is u v prime plus v prime. So after we find the values, we just substitute to the formula. But for v1 prime, we need to use v. V is equal to log 3x. So log 3x, it will be 1 per 3x. Because log something equal to 1 per something. So we can sum up the 3, it will be 1 per x. So after we substitute, we got y per x plus log 3x, dy per dx. So we just copy and we continue to differentiate e power of 2x plus 1 and negative tan 4y equal to 0. So after we differentiate e and 2x plus 1, we will get 2e 2x plus 1 because 1 is constant. So for tan, we need to differentiate and we will be secant square. Then we differentiate fy, it will be fy, and then f dy by dx equal to 0. And then we need to put 4 to the front and it will be 4 secant square for y dy by dx equal to 0. And then we put dy by dx on the left side. So it will be log 3x dy by dx minus with 4 secant square for y dy by dx equal to 2e 2x plus 1 minus with y per x. So we need to factorize dy dx. So dy by dx over bracket log 3x minus with 4 secant square for y close the bracket equal to 2e 2x plus 1 negative y per x. So the question asks for dy by dx. So we just dy by dx equal to 2e 2x plus 1 minus with y per x divided by log 3x negative 4 secant square for y. So this is the final answer. Lastly, our question is question 4. They ask, use linear approximation to estimate the value of 4 square root 80.99 minus 2 over square root 80.99 correct to 3 decimal places. So we're going to extract our equation. So our solution is we're going to use the formula for linear approximation, which is fx with fx naught minus f prime x naught multiplied with dx, where fx is x minus x naught. So where do we get our value of x? We get it from our equation. And where do we get our x naught? We're going to get it from the nearest value to 80.99, which is 81. And we can confirm whether or not this value, we can use it by inserting it in our equation. First part, which is 4 square root and the square root of. So here, how can we confirm it that we can use the value? We have to make sure that it's a whole number and not in decimals. Okay, so since we get our value, we're going to use the formula dx equals to x minus x naught, which is 80.99 minus 81. So we're going to get negative 0.01. So we're going to fs. We're going to use the equation given. So it's going to be fs equals to 4 square root of x minus 2 over square root of x. But since we're going to differentiate it, we need to make it more simpler. So we're going to make the 4 square root into a power. So it will be x to the power of 1 over 4. And for 2 over square root of x, we're going to take the square root up with 2. So it's going to be 2 minus 2x to the power of negative 1 over 2. So now we can differentiate. So this, our f prime is f prime x equals to 1 over 4x to the power of minus 3 over 4. So this is the product. And then we're going to minus it with minus x to the power of negative 3 over 2. And we're going to make it more simpler by not having it in the form of negative. So we're going to bring the x, negative 3 over 4, downwards, which we're going to get 1 over 4 over x to the power of 3 over 4, plus 1 over x 3 to the power of 2. And now we're going to get into linear approximation. So we're just going to enter our value. It will be f 80.99 with f 81 minus f prime 81 with our dx value negative 0.01. So we're just going to insert the value inside the formula here. When we insert this value into the calculator, we're going to get the final answer, which is 2.778. And we can confirm this value by using this whole equation and insert it into the calculator. And we will get the same value, which is 2.778. That's all. Thank you.